Okay, grade 11, let's have a look at the rest of question 3. And the rest of question 3 is asking us here, calculate the chi-squared statistic for this data, and then what conclusion can we make for this test, and give a reason for your answer. And there's a couple of ways that we'll be able to do this. So let's have a look at our results here, and this is the table here that we calculated before. If you can't remember from the previous video how we did that, don't forget we have our data stored in S already. We went into our statistic tests. We always do a two-way test for our chi-squared because we're always looking at two variables. The goodness of fit is one variable chi-squared we've got to worry about. Our observed matrix here is S. It's going to have all those other stats in there from our previous calculation. And here's the table there. And the important ones are, we can see our degree of freedom, our p-value, and our chi-squared value. And I've cut and pasted that across here. So calculate the chi-squared statistic for this data. All you need to do is say, calculated from our graphics display calculator, there's our chi-squared 9.83. And if we look at our results here, 9.83, 2 marks. Straight away, very easy. They have this one if you calculate it from the integer values, we don't worry about that. So, the next part says, the chi-squared critical value for 4 degrees of freedom, that's what we've got, at the 5% significance level is 9.488. If you look at old exams prior to 2014 from the IB, they may ask you to calculate the critical value. Back in those days, they used to be the table and you'd have to look up the table. They've gotten rid of that for you guys. So they'll always give you the critical value for whatever degrees of freedom and whatever level of significance, just like this question is done. So if you're looking at old exams, don't worry about it, you can skip over that. So 9.488, our value is 9.83. What conclusions can we draw from this test? This is where we need to remember our graph here. They've given you the critical value. Our value here, 9.83, is bigger than the critical value. If it's bigger, we reject H0. Our H0 is stress is independent of travel time. So here, we're going to say that the conclusion is that we are going to reject that and that stress is not independent of travel time. Okay, so stress depends on travel time. So that's a really interesting thing there because we've rejected our null hypothesis. How they word this here, do not accept the null hypothesis. Level stress is not independent of travel time or reasonable equivalent. The reason why is that because of our thing from the graph there, that we can show that it's our calculated is bigger than our critical. Another way that we can do this, and don't forget this is another way, is that our p-value we can also calculate. Our p-value over here was 0.04, 0.04337, 0.0434. That is less than 5%. So if our p-value is less than 5%, which is 0.05, that's another way that we can reject the null hypothesis. So one is if our calculated chi-squared is bigger than our critical. One is if our p-value is smaller than the value given for the level of significance. Generally, the critical value is going to be the one, but you need to remember the other one just in case.